In this notes walkthrough, we'll talk about how to find slope of a line given 2 points, how to find slope of a graphed line, and to find and interpret rate of change. The first thing that you need to know about slope is that it's the ratio of a line's vertical change to its horizontal change. So as soon as you hear that it's a ratio, understand that slope will most often be expressed as a fraction. A synonym for slope is steepness. So slope will tell you how steep a line is, but slope will also tell you the direction of a line. So down here you can actually see direction. And when we read lines, we read the same way that we read language, left to right. So if we go left to right, we're going up, so that would be a positive slope. And if you kind of think of it about if you put someone walking on that line, if they're walking left to right, they'd be walking uphill. If you read this line left to right, it's going down, so that would be a negative slope. And we'll get more into why these two are 0 and undefined, but the horizontal line at the bottom here would be a 0 slope, and this line right here would be undefined. The reason that a positive slope line is considered to be that way is if you picture a coordinate plane with your x-axis and your y-axis. So remember, x is the horizontal axis, the y is the vertical axis. So as we move to left to right on the x-axis, that would be x increasing. On a positive slope line, as we move left to right, y is also increasing. So that would be a positive slope line. And then for a negative slope line, we're still reading left to right, so x is still increasing. But this time, since we're going down, y is decreasing. For a 0 slope line, as x increases, so we're still moving left to right, we're not moving up or down, so y is actually staying the same. And then for undefined, the problem is all of these have started with as x increases, which means we're moving left to right in the graph. Here, x isn't increasing, so we cannot define it the same way we define the others. So if we go back to our formulas, the first formula that we're going to use for slope is m is going to be the letter that we use for slope. I don't really know why, other than maybe m mountain. I'm going to make my fraction bar. So to find slope, one formula could be y2, that's not an exponent, it's a subscript, minus y1 over x2 minus x1. And we're going to use that formula when we have 2 points, or 2 coordinates. So this x, this y2, and this y1 is just, it's a way of saying, here's one of the y coordinates, here's another. Here's one of the x coordinates, here's another. Another formula that we can use for slope is m equals rise over run. And we're going to use that when we're given a graphed line. And another formula, which is actually the same thing as rise over run, it's just a little more mathematical, would be m equals delta y over delta x. And remember that the Greek letter delta means change in, so this would mean the change in y, which if you come over here to our definition, that's our vertical change, the y is the vertical axis, horizontal change. So changes are delta, horizontal is x, delta y on the bottom, vertical change on the top. And again, we would use that formula when we're given a graphed line. Most people use rise over run when you get to the high school. You'll most frequently see delta y over delta x, but these two formulas right here really mean the exact same thing. At this point, I want you to pause the video and go on to slide 2. There's going to be a part on slide 2 that asks you to come back to slide 1. And when it does, you're going to come back here and you're going to press play. So what you just saw on slide 2 is that sometimes when you're using the y2 minus y1 slope formula, you get a 0 in a certain spot of the fraction. So when it's undefined, what's going to happen is when you do y2 minus y1, you're going to get some number. It could be positive, it could be negative, it could be a fraction, it could be a decimal. It really doesn't matter. But what's most important is that you're going to get a 0 on the bottom. So when you get undefined, it's going to look like that, keeping in mind that your final answer is actually undefined. And the hint that I can give you is if the 0 is under the line, it's undefined. It's just kind of a little rhyme to remember that. The other thing is if you type that into a calculator, whatever that number is divided by 0, the calculator will say error. And again, that's not your slope, but it should be some kind of an indicator to you, okay, something's off, so that's going to be my undefined. And then if you have a 0 slope, when you do y2 minus y1, you're going to get 0 on the top, and you're going to get some number on the bottom, which if you type that into a calculator, it'll actually spit out the number 0. So at this point, you're going to jump ahead to slide 3 to see how to use the other two slope formulas, rise over run and delta y over delta x. So on this slide, we're going to find the slope of the line that passes through the given point. So I'm going to use the formula m equals y2 minus y1 over x2 minus x1. Because on the previous slide, it said that you should use this formula when you're given 2 points. And here's my first point, here's my second point. So before I continue on, I'm actually going to label my points so I know that 5 is an x-coordinate, 2 is a y-coordinate, 4 is an x-coordinate, negative 1 is a y-coordinate. Now I want to label one of these as x1, x2, y1, y2. So if we're reading left to right, 5 comes first, so that would be my first x, which would make 4 my second x, or x2. 2 is y1, negative 1 is y2. The next thing I'm going to do, just to make sure my signs stay the way I want them to, I'm going to actually rewrite the formula m equals fraction bar, and I'm going to take these two subtraction signs and I'm going to bring them down. So essentially I'm leaving a blank space where y2 is, so I want to fill that with a number. y1 I want to fill that with a number. x2, x1 I'm going to pull right from here. So the first number I'm going to replace is y2, which is negative 1, and that's going to go right there. So negative 1 minus y2 is 2. y1 is 2, I'm sorry, y1, so I'm going to put a 2 there. x2 is 4 minus x1 is 5. Now that I've plugged in all my numbers, I can actually do the math. So on the top, I'm going to rewrite it as negative 1 plus negative 2, and on the bottom, I'm going to rewrite it as 4 plus negative 5, which would be negative 3 over negative 1, which would simplify to 3. So the slope of this line is 3. So for each of the 4 examples that you see, 1, 2, 3, 4, you're going to pause the video. I want you to start with the formula each time, plug in the numbers accurately, then make the change to plus negative or plus positive if needed. Your final answer can either be a whole number or a simplified fraction. What you don't want to have is decimals or mixed numbers. Pause the video, press play when you're ready to check your answer. So in this first example, after writing the formula, labeling my ordered pairs, you end up with 6 minus 3, which is just 3, 4 minus negative 2, which becomes plus positive, which is 6, and that reduces to 1/2. On the next example, people get a little scared of this one because it has fractions, but it actually comes out pretty nice. So y2 is negative 3 minus 5. I would change it to plus negative, and that's negative 8. And then I have x2, which is 1/2, minus 9 over 2, so plus negative, and I did that over here. They already have a common denominator. Keep my denominators of 2, add my numerators. Negative 8 over 2 is negative 4, so that comes down here to that answer. So I took this work and did it over here. I just put my answer in. And then negative 8 over negative 4 simplifies to 2. So that's my final answer for that one. Here, if I do y2 minus y1, I get 4 minus 4, which is 0. Negative 2 plus negative 3, which is negative 5. And if you actually type that into a calculator, 0 divided by negative 5 is 0. So our final answer on this one is going to be 0. You don't want to leave it as 0 over negative 5. You absolutely want to make it 0. And then on the last one, if you do y2 minus y1, you get 3 minus 1, which is 2. Negative 5 minus negative 5, you change it to plus positive, and that's 0. Now if you type into a calculator, 2 divided by 0, it'll actually say error. We can't have error for a slope, but that's going to be our undefined. At this point, you're going to pause the video and you're going to go back to slide 1 and press play at the end of that slide. So on this page, you're given 6 examples and you're given graph lines of each. Now, because you're actually given the coordinates, 0, 5, and negative 1, 0, I mean, if you really wanted to, you could do y2 minus y1 over x2 minus x1, but I just want to make sure that you can do rise over run, so that's actually the formula that we're going to use. So rise is just how far apart are the 2 points up and down, and run is how far apart are the 2 points left and right. So if you think of it as your objective is to get from this point here to this point here, but you can only walk horizontally or vertically, that's what you're trying to do. And so the horizontal distance is your run, and the vertical distance is your rise. So to get from negative 1, 0 to 0, 5, you go one distance from here to here, so that's 1. And then vertically you would go 1, 2, 3, 4, 5. So if I draw that in, 1, 2, 3, 4, 5. And so then if I use rise over run, you're going to get 5 over 1, which would just simplify to 5. On the next example, we'll do this one together, and then I'll have you do a couple on your own. Again, you're trying to get from this point here to this point here, and you can only go vertically or horizontally. So I'll start by going 2, 4, 6, 8. And the reason I counted by 2 is because each of these blocks was worth 2. So 2, 4, 6, 8. And then 2, 4. So this time, if I use rise over run, I would get 8 over 4, which is 2. So one thing you have to be really careful of when you're doing rise over run is you have to decide at the end, does the line have a positive slope or a negative slope? So if you just look at this line, and when you read it left to right, it's trending downward, that just means that it has a negative slope. So in the end, you don't have to say the word negative, but you just throw in the negative sign to show that it's a negative slope, so negative 2. So you're going to pause the video, you're going to try the next 4, and press play when you're ready to check. On this one down here, it's a little bit difficult to see the points, but you can kind of see how you can see the points here. You can kind of look to see, okay, where can I put points, and just at a place where the line crosses at a corner would be good. Pause the video, press play when you're ready to check your answers. So in the first example, you can see that it's a rise of 1, 2, 3, and a run of 1, 2, 3, 4. So 3/4. The line has a positive slope, so I don't have to make any adjustments in the end. This one over here, you have a rise of 2, 1, 2, and a run of 3, so 2/3, and again, it's a positive slope. You don't have to make any adjustments. This one, a lot of people tend to get wrong the first time because they always start at the origin. Keep in mind, you're not trying to get from this point to the origin or from this point to the origin. You're trying to get from this point here all the way to this point here, moving vertically and horizontally. So to do that, I'd have to go 1, 2, 3 spaces. That's my rise. 1, 2, 3, 4, 5, 6, 7. That's my run. So you put them in a fraction, you get 3/7, but then you also have to make sure that you include the negative sign just because this line has a negative slope. Here I just happen to pick these 2 points, and that has a rise of 3 and a run of 1, and which simplifies to 3, but again the slope is negative. If you had used these 2 points, you would have had a rise of 6 and a run of 2, which still comes out to a slope of 3, and it's still negative. So rate of change doesn't act much differently than slope, it's just slope in the real world. And what you need to do when you're doing rate of change is you need to include your units and express it as a unit rate. So unit rates have a denominator of 1. So for that first example, it says gas prices went from $3 to $4 between June 1st and August 1st of that same year. I'm going to try to find the rate of change for the price of gas during that time period. So to do this, I think the easiest formula actually to use is delta y over delta x, change in y over change in x. But I'm comparing gas prices, so dollars, and days. So I'm actually going to go back to this idea that y depends on x. And in this problem, the dollars or the price is going to depend on the days. So that means that the dollars is really my y. So when I'm finding change in y, I'm really finding change in dollars. And when I'm finding delta x, I'm really finding change in days. And so obviously $3 to $4 is a change of $1. And June 1st to August 1st, so that would be 30 days in June, 31 days in July, and then August 1st I'll include, so that'll be 62 days. So this tells me that in a 62-day period, the price of gas went up by $1, but I want to figure out how much it went up in 1 day. So to do that, I would divide top and bottom by 62, and 1 divided by 62 comes out to 0.016. So this would be 1 cent right here, almost 2 cents if you were to round it, but I'm actually going to keep it like that. So you can see I did my slope formula, I kept my units all the way through, dollars and days, because I can actually see what's changing. And in the end, I just made it a unit rate. So from June 1st to August 1st, it went up by almost 2 cents a day, but I'm going to keep the 3 decimal places. So now I'm going to do the same thing for the next one, which said they fell back to $2 by November 19th. So in this time period, still finding change in money, change in days. So I want you to try this part on your own. Try to set up this fraction right here. How much did it change by, and in how many days? Pause the video, press play when you're ready to check just that piece. So this time, gas prices are going from that $4 back to $2. So this time it's a negative change because they're going down. They went down by $2. And then it's from August to November 19th. So that's 31 days in August, 30 days in September, 31 days in October, and then the 19 days in November makes 111 days. So your next objective, and you're going to do the next two parts on your own, you're going to now change this into a unit rate to figure out how much it changed in one day. And then compare these two answers that you're going to get to figure out which one had the greater rate of change and why. Pause the video, press play when you're ready to check your answer. So if you divide top and bottom by 111, you get negative 0.018. So even though these would both round to 2 cents, this one is slightly bigger because the 8's bigger than the 6. So that means actually the second rate of change is actually greater. Even though it's negative, it's going down, and this one's going up. The second one's going down at a slightly faster rate. It'd be steeper because this number is bigger. Try the next one for rate of change. Make sure in your final answer you include both your units like we did up here, dollars and days, and that in your final answer it's expressed as a unit rate. Pause the video, press play when you're ready to check your answer. So the first thing I figured out in this one is if y depends on x, then cost depends on time. That means that delta y is really delta money, which the money is changing by 7 each time. And this is in a 2-hour period, so my change in time is 2 hours. So $7 in 2 hours. If you divide top and bottom by 2 to make it into a unit rate, $3.50 per hour.